Hey guys, welcome back to VR Revision. Today we're covering topic 3, circular functions and trigonometry. So before we start discussing circular functions and trigonometry, we must first establish one basic unit that you're going to be using throughout this whole topic. That being radians. How do you calculate radians? Well, say you have 90-degree angle and you have to convert that into radians. What you do is you grab the value 90, then you multiply it by pi over 80. This converts into pi over 2, and that is the symbol you use. That's what you use for radians. You can also see it on the unit circle, but I will explain this in a second. So first, we must establish two formulas that you can be used throughout the whole subject. And the first one is to calculate the length of an arc, which is the length equal to theta times r. Theta is in radians, like I showed you just now. You have to calculate it in radians, otherwise this formula is inconclusive. And r is the radius. Simple. Then you have the other formula, which is the area of a sector. So the area is equal to half theta r squared. Since we are dealing with the same sort of question, theta is again in radians and r squared is the radius of the circle. Make sure that you do convert from radians if you have a diameter, because you will make this equation malfunction. Now, moving on to trigonometric identities, we already know that these are the main formulas for sine, cosine, and tangent. However, we can also calculate the tangent, so tan of theta, by doing the sine of theta over the cos of theta. How do we know this? Well, going back to the unit circle, here on the x-axis, we have it labeled as cosine, and the y-axis is sine. So when you do sine over cos, the tangent will be the tan angle. So we also have the reciprocals of these formulas, which go as follows. You have sec theta, which is 1 over the cos of theta. So this would be the reciprocal of cosine. And then you also have cosec, which is 1 over sine theta, which, as entails, is the reciprocal of the sine. So you also have arcsine, arccos, and arctan for each equation. However, on your calculator, you write it as sine, cosine, or tan to the -1. If you're using a TI-84, it's second and whichever you're using, sine, cosine, or tangent. These are equivalent to the arc of the value. So another thing that you have within trigonometry are the Pythagorean identities. These are not the Pythagorean identities, so do not get confused. The Pythagorean identities is, well, there are 3, but the main one that you would know or need to know to calculate the other ones is cos squared theta plus sine squared theta equals to 1. From this equation, you can calculate most equations, and it also helps you with simplifying your work. The one that is followed from this is 1 plus the tan squared of theta to equal sec squared theta, which is a derivative of this. Well, derivative. You can calculate this using this. And then the last one that you have is 1 plus cot squared theta equal to cosec squared theta. So an easy way to calculate the cosine and the sine in an exam of paper 1 where you cannot use your calculator would be using this table. So what you do is you write down sine and cosine depending on which one you're calculating, and then you write the angles at the top. What you do from there is you count from 0 to 4 from left to right for sine, and from cosine you do from right to left. So what that gives you is a complex table like this, which is really easy to understand. But these values are not the actual answer. What you have to do from there is you have to do the square roots of that value and then divide it by 2. And that will give you your answer. Here we have an example of sine 90. We all know that's equal to 1 because of the unit circle. As we can see here, y is equal to 1 when cosine is 0. So 1 is your value for 90. So what we do here is we we went to the table, we got sine 90 is the number 4, so we put it into here. 4, the square root of 4 is 2, and 2 over 2 is equal to 1. So this is a quick way to calculating the value of sine or cosine without using your calculator. Moving on to compound angle identities, we have three main ones for each angle identity, so sine, cosine, and tangent. So for sine, a plus or minus b is equal to the sine a of cosine b plus or minus the sine, sine or cos, sorry?
Sine.
Yeah.
It doesn't matter, sine or b.
Sine b of cos a. Hopefully you can see it. If not, it will be projected right now on the screen. So to calculate using these formulas, say you have to calculate sine 75. With a calculator it's very easy, but without a calculator you can apply this formula and then this is what it becomes. So sine 75, it will become sine 30 plus 45. So there you have your A and B angles or values. You plug them into this equation and there you have your answer. Using the table that I mentioned previously, it's really easy to do because once you have the table written down and you find the values, all you have to do is substitute those values into this equation and then you have your answer. So for the value of cosine of A plus or minus B is equal to cos A times B, and whatever symbol is in here, this one will be inverted. So then you also, after that symbol, you have sine A, sine B. The last one we have is tan A plus B, plus or minus B. So this one's the largest one of the three. However, it's still pretty simple to do. So you have tan A plus or minus tan B over 1 minus or plus. So again, we have the inverted sign at the bottom. Plus, so then it's tan A tan B. All these equations will have popped up in the middle of the screen every time I'm writing them on here. So if you can't read this, you will at least be able to see them on screen. Alright. Following these equations, we have the double angle identities, which means basically what the name says, you have double the angle. So for sine 2 theta, this is the notation for a double angle. So whenever you see this, you know you have to go to double angle identities and not to trigonometric identities or compound angles or whatever. So sine 2 theta is equal to 2 times sine theta times cosine theta. So these equations usually pop up in your exams and then you are forced to rearrange them to find a value, and then that's how you find the answer to a double angle. So the other double cosine of 2 theta has multiple ways of writing it. The first one is cos squared minus sine squared, and then you can find your double angle. The other form to write this one is 2 times cos squared theta minus 1. And then the third way of writing this equation is 1 minus 2 sine squared theta. All these equations are in your formula booklet if you're doing the IB. If not, memorize them. They're not too complicated. They're easy to know. So good luck. The last one we have here for double identities is the tan of 2 theta. This one is equal to 2 times tan theta over 1 minus tan squared theta. Reaching the conclusion of circular functions and trigonometry, we have 3 more rules that we have to learn. Cosine rule, sine rule, and area of a triangle. You might be looking at me like, why do I have to learn the area of a triangle again? I will explain them when we get there. So these 3 rules are applied when you do not have a right angle triangle. So the first one is the cosine rule. There's 2 ways of writing this. So the first one is sine squared is equal to a squared plus b squared minus 2 times the value of a and b times the sine of c. You can also rearrange this formula to be equal to any letter. Just make sure that you use the same values in each section and rearrange it accordingly. The other way of writing the cosine rule is by writing cos of c being equal to a squared plus b squared minus c squared over 2 times ab. As you can tell, this formula can be calculated from this other formula, the first one that I mentioned. So if you forget the second one, don't panic in the exam. Just know that if you know the first one, you can calculate the second one. The next rule that we mentioned was a sine rule. This one's probably the most straightforward of the three of the rules of sine or cosine, because it's written like this. A is equal to sine A. A over sine A is equal to B over sine B, which is equal to C over sine C. Straightforward. However, as you can see on the diagram on the screen right now, the A's and the B's have differences. So if you have a capital A, we're talking about the angle. And if we're talking about the small a, we're talking about the value or the length of said angle opposite to the angle with the capital letter. And finally, we are reaching the conclusion with area of a triangle. The formula is as straightforward as A being equal to a half A times B times sine C. As you can tell, we're using the angle of the triangle to calculate the whole area, much like you wouldn't do this with a right angle triangle, because the triangle is a 90-degree angle, so then this would become 90, and as I showed in the example before, sine of 90 is 1. So that is why there's a difference within the examples. Well, thank you guys for watching this video. Hope you guys enjoyed it, and we will see you in our next mathematical video.
Hi, thanks for watching this video from our video revision series. To watch other videos from this subject, click the playlist on the right. And to see the bloopers of this video, click the video to the left. Make sure to leave a comment with any topics, suggestions you may have, and subscribe to see when it comes out.